Today we're going to be looking at section 9.4, which is about adding and subtracting rational numbers. So we're going to learn how to, rational expressions. So we're going to learn how to add and subtract rational expressions and then simplify complex rational expressions having sums in the numerator or denominator. So one thing that we can keep in mind is that adding and subtracting rational expressions follows the same process as adding and subtracting fractions. So you can see the same process that was from elementary school when you learned how to add fractions together. You're going to see the same process now as you add rational expressions. So let's look at some elementary adding fractions and look at that process and then have that process help us with the adding and subtracting rational expressions. So let's begin with 5/3 plus 2/3. So when I add 5/3 and 2/3, since the denominator is the same, I keep my denominator and I add my numerator. And then 5 plus 2 simplifies to 7. So my answer is 7/3. Another example of adding fractions that's a little bit more complex is if I have something like this. 3/5 minus 2/7. Now, in this case, my denominators are different, so I cannot just write it over as one fraction. I actually have to come up with a new denominator, and I want my new denominator to be the least common multiple, or we call it the least common denominator for 5 and 7. So the least common multiple for 5 and 7 is going to be 35. And so that means that my new denominator for this fraction is 35. And if I change 5 to 35, I had to multiply by 7. So that means I have to multiply 3 by 7, which will be 21. And then my new denominator for 2/7 is going to become 35. But if I change 7 to 35 by multiplying by 5, then I had to multiply my numerator by 5. And 2 times 5 is 10. So now I am subtracting two fractions that have the same denominator, which means I can go ahead and write this as one fraction. So I have 21 minus 10 over 35, and then 21 minus 10 is 11. So I have 11/35. All right, so to add or subtract fractions and rational expressions, there are three things that you want to remember, okay? So here are the three things. So to add or subtract fractions and rational numbers, we're going to call them rational expressions since they have variables in them. So first thing to remember, make sure that the expressions have a common denominator. All right, so you have to do that before you add, subtract, anything. You have to make sure they have a common denominator first. After that, after they have a common denominator, you add or subtract the numerators. And you place the result, after you add or subtract the numerators, you place that result over the denominator. And then the last thing that you need to do is to simplify. You want to simplify the result. All right, so let's look at an example of subtracting a rational expression, okay? So this is our first example. We're going to subtract 2x plus 5 over x minus 1. We're going to subtract 6x minus 3 over x minus 1. So you know that my big thing is anytime I do anything before I begin, I'm going to go ahead and identify where my groups are, right? So here are my groups, right? So now I want to make sure that my denominator is the same. The denominator for this fraction is x minus 1. And the denominator for this fraction is x minus 1. That's perfect. I don't have to think about having to change or anything. I can just write x minus 1. Now I can write the numerator on the top. So I have 2x plus 5 minus 6x minus 3. So notice how I wrote that all as one big fraction, and I only had to write the denominator once. So from here, I'm going to subtract the numerator, right? So I'm going to distribute the subtraction. So now I have 2x plus 5. That becomes minus 6x, and that becomes a minus negative 3, which is plus 3, and then all over x minus 1. Okay, so now I can combine some like terms. So I have 2x minus 6x, that's going to be negative 4x. And then I have a 5 plus 3, that becomes 8. And then over x minus 1. And then we're done. That cannot be simplified. All right, so sometimes we have to adjust the denominator. For example, if one denominator is y minus 1 and the other one is 1 minus y, like those look almost the same, but they're not quite the same. So look at this. I have y minus 1 versus 1 minus y. The reason that these are not the same denominator is because the y is positive over here, and the y is negative over here. My 1 is negative over here, my 1's positive over here. So it's a sign that's different. So although they're similar, they're not equal, okay? However, I can manipulate a couple of things to make them work. So for example, if I do negative 1 times 1 minus y, okay, then that becomes negative 1 plus y, which is the same as saying y minus 1, which then becomes like this one over here. So what I did is I took this guy and I was like, you know what, I want him to look like this, so I'm just going to multiply everything by negative 1. However, I would have to take that negative 1 and multiply the numerator by negative 1 as well, okay? So this changes the form of the expression, but not the value of the expression, as long as you multiply both numerator and denominator by the same negative 1. So let's look at an example of doing that. Let's look at our second example here. So we want to do 5x plus 4 and then x minus 3 plus 3x minus 1 over 3 minus x. So I noticed that my denominator is very similar but not equal, right? This x is positive, this x is negative, this 3 is negative, and this 3 is positive. So what I'm going to do is I'm going to take, first of all, I'm going to identify all my groupings. There we go. And then I'm going to take this 3 minus x, and I know that I want those signs to change. So I'm going to multiply the top and the bottom of this rational expression or this fraction by negative 1. So now I still have the 5x plus 4 and the x minus 3 over here. I didn't change anything over there. We'll keep those groupings. And then I had to multiply everything in the numerator by negative 1. So that becomes negative 3x, and then plus 1, because negative 1 times 3x, negative 3x. Negative 1 times negative 1 becomes plus 1, over negative 1 times 3 is negative 3. Negative 1 times negative x becomes plus x. And then I can use my commutative property to rearrange those two terms. So I have 5x plus 4, x minus 3. I have negative 3x plus 1. And I'm going to rearrange those terms right there. So now I have x minus 3. Now my denominator is the same. And now that my denominator is the same, I can write it as one fraction, right? So one fraction with x minus 3 as my denominator. Here's my first part at 5x plus 4. We're adding. And then here's my second part, negative 3x plus 1. So I have nothing to distribute in front of those parentheses, so I can just combine like terms. We'll rewrite it first though. So I have 5x plus 4 plus the negative 3x, which means minus 3x, plus the positive 1, which is just plus 1. And I have x minus 3. So combining like terms, we'll start with 5x minus 3x. That's going to become 2x. And then we have a 4 plus a 1, that becomes plus 5 over our x minus 3. All right, so now that we've talked about that, so that was a simple change in our denominator to make our denominators the same. But to add or subtract rational expressions that have completely different denominators, we want to obtain the common denominator by multiply it by the appropriate forms of 1. And what that means is that whatever you multiply the denominator by, you have to multiply the numerator by. All right, so the first thing we want to do is find the common denominator. All right, so how to find the common denominator? This is what we do. Before you begin, you know how I make a big deal about finding your groups, right? Well, sometimes your groups aren't there because it's not factored yet. So you want to go ahead and factor into prime factors, right? So if it's a trinomial, go ahead and you reverse box method it so that way you can see all of the factors, right? So step 1 is going to be to factor. You want to factor into prime factors. So factor it as much as it will go. Okay, and then the second thing you want to do is use the least common multiple as your common denominator. That's what you're going to use, okay? So let's look at an example of doing that, all right? So we're going to do example 3. So we have 5x, and we have x squared plus x minus 6, and we're going to add x plus 7 over x squared minus 4x plus 4. So notice here are my groupings, right? Okay, so what I need to do before I try to figure out what my common denominator is I need to factor, right? So this guy, I'm going to take over here and factor him over here. So we're looking for x squared, looking for negative 6, but it has to add up to x. So we'll definitely do x and x. And then we can do, let's try 3 and negative 2, right? Because that adds to negative 6, but then negative 2x plus 3x becomes just x, so that works, okay? So now I have 5x over x plus 3, x minus 2, okay? Now I'm going to take this guy and factor him over here. So he becomes, let's see, x squared, 4, and we're adding up to negative 4x, right? So x and x here for sure. So 4, we can do 4 and 1, but I don't see how that's going to add up to 4. We could do 2 and 2, but 2x plus 2x is 4x, not negative 4x. However, we could do negative 2, because negative 2 times negative 2 is positive 4. Then we get negative 2x minus 2x, and that becomes negative 4x. So that works. All right, so we have x plus 7 over x minus 2, x minus 2. All right, so now we need to find our least common multiple. All right, so looking at all of our multiples, we have an x plus 3, we have an x minus 2, we have another x minus, we have an x minus 2 and another x minus 2. So at minimum, everyone has to have an x plus 3 and 2 x minus 2's. So this guy is missing an x minus 2. So we're going to multiply by x minus 2. This guy is missing an x plus 3. So we're going to multiply by x plus 3. Okay, so when we multiply by that, so we have 5x times x minus 2, that distributes, right? So 5x times x, that's 5x squared. 5x minus 2 is negative 10x, okay? And then this right here, x plus 5 times x plus 3, that's going to be a box method. So we're going to take this and we're going to do a little box right here. So we'll do x plus 5, x plus 3. So x times x is x squared, 5x, 3x, and then 15. So whenever we multiply those two together, we get x squared. 5x plus 3x is 8x, and then we get 15. And that's all over our common denominator of x minus 2, x plus 3, and then another x minus 2. All right, so what we want to do now is we want to simplify. So I'm looking at this numerator, and I'm going to combine some like terms. So 5x squared plus x squared, that becomes 6x squared. And then negative 10x and plus 8x becomes negative 2x. And then I also have that plus 15. And then all over x minus 2, x plus 3, and another x minus 2. All right, so from here, you know what, let's go back and check our work real fast. I believe we made one mistake. This was supposed to be x plus 7, so that should be a 7 right there, which changes this right here. So that should be 7x, and that should be 21. So 7x plus 3x is 10x. So we have negative 10x plus 10x, which completely goes away. That cancels. And then also 7 times 3 is 21. So this becomes a 21. There we go. That's better. All right, so now we have, I'll write a clean, we have 6x squared plus 21. So what we'll do is we'll go ahead and factor out a 3 from that, because 6 and 21 have a factor of 3. And we're left with 2x squared plus 7 over, we have this x plus 3, and instead of writing x minus 2 times x minus 2, I'm going to write x minus 2 squared. That way it's a little more simplified and nice and clean. All right, and then that's it. That's as much simplified as it can go, because this does not cancel either of those. So that's example 3. All right, so let's do another one, trying to find common denominators. We're going to do example 4. So for this example, we have 4x plus 2 over x squared plus 11x plus 30. And we're subtracting x minus 1. I'm already putting my grouping symbols in there. X squared plus 2x minus 24. So I'm going to go ahead and show where those groups are. All right, so we need to do some factoring. All right. I'm going to label this one. So I'm going to label this A. I'm going to label that B. Okay. So here's the factoring for A. Right? So we have x squared, 30, and we want to add up to 11x. So 6 times 5 is 30, and 6x plus 5x adds up to 11x, so that works. So our A is going to become x plus 6, x plus 5. So we have 4x plus 2. You know what? Let's go ahead and factor out 4x plus 2. We can factor out a 2. So let's go ahead and factor out a 2. So we have 2, and then we have 2x plus 1, right? Factoring out a 2 there. And then over this piece here became x plus 6 and x plus 5. All right, then we have minus. Let's go ahead and factor b out. So we're looking for x squared, negative 24, but adding up to 2x. Let's see. There's 2 and 12, but I'm not seeing how that can add up to 24. There's 8 and 3. There is 6 and 4. That might work, right? If we do a positive 6 and a negative 4, because that adds up to, that multiplies to negative 24, but then adds up to positive 2x, because negative 4x plus 6x is 2x. All right, so we have our factors for b. It's x plus 6 and x minus 4. So we have x minus 1 over, this becomes x plus 6 over x minus 4. All right, so now we need to identify our least common multiple. So this guy has an x plus 6 and an x plus 5. This guy has an x plus 6 and an x minus 4. So if I'm looking at this guy and I'm comparing to him, I'm thinking, what does this guy not have that this guy does, right? So they both have an x plus 6, so that's good. But this guy doesn't have an x minus 4, so we need to multiply x minus 4 over here. Okay? And then this guy over here, he has an x plus 4, right? And we both have an x minus 4 because we had to make that. But this guy doesn't have an x plus 5. So we're going to put an x plus 5 over here. All right? So from here, we have to multiply out the numerator, right? So we had factored out a 2 here, hoping that something would cancel, and nothing canceled. So what we're going to do is we're actually going to have to go back to what we originally had, this 4x plus 2, right? This was originally 4x plus 2. And we're going to keep it like that since nothing canceled out on the bottom. We hoped it would, but it didn't. So we had to multiply x minus 4 and 4x plus 2. So I'm going to call that C. And then we're going to call this over here D. So here's C. So we're doing x minus 4 and then 4x plus 2. So we get 4x squared. We get negative 16x. We get 2x. We get negative 8. So this part of our numerator is going to be 4x squared. 2x minus 16x is negative 14x. Then minus 8. And then, remember we're subtracting. All right, so now let's do part D, right? So part D, we are doing x minus 1 and x plus 5. So we get x squared, negative x, 5x, and then negative 5, right? So this is x squared. 5x minus x becomes 4x. And then we have minus 5. And that's all over our x minus 4, our x plus 6, and our x plus 5. right, so now we need to distribute that subtraction, right, because we're subtracting these two. So I have 4x squared minus 14x minus 8 minus x squared minus 4x minus negative 5, which is plus 5, all over x minus 4, x plus 6, x plus 5. So now we're doing some simplifying. So 4x squared minus x squared becomes 3x squared. And then negative 14x minus 4x becomes negative 18x. And then negative 8 plus 5 becomes negative 3. All right, so this actually can be simplified a little bit more. You can factor out the 3, okay, in the numerator, right? Because they all have a factor of 3. So that just makes your final answer 3x squared minus 6x minus 1. And then what you would have to do is you would actually have to look at that x squared minus 6x minus 1, and you would have to try to factor it, because if it can be factored, it might be able to cancel one of those things in the denominator and simplify. But, well, I'll let you know right now that x squared minus 6x minus 1, that doesn't factor, that doesn't simplify, so this is as far as this one goes. All right, let's do example 5. So in this one, we have a complex fraction, and we're going to use the idea of division to simplify a complex fraction, right? So this is where we're kind of using tricks, right? We're going to have 5 plus 1 over x over 25 minus 1 over x squared, okay? So what we're doing is we're using the idea of division, right? So the first thing we want to do is I want to get rid of this this 1 over x squared. Yes? So what I'm going to do is I'm going to multiply my numerator and my denominator by x squared. And all I'm trying to do is get rid of that x squared and that lowest denominator, right? So what happens is I have 25, well, let's start with the numerator. 5 times x squared, that becomes 5x squared, right? And then 1 over x times x squared. Well, that x cancels one of those x's, just leaving me x. And then at my bottom, I have 25 times x squared. That's 25x squared. And then minus, and then this 1 over x squared times x squared cancels. So I'm actually just left with 1. All right? So from here, what I will be doing is I'm going to factor out an x in the numerator. So I have x, 5x plus 1. And then on the bottom, 25x squared minus 1 is difference of squares. So that becomes 5x plus 1, and then 5x minus 1. And then notice I have a 5x plus 1 on the top and the bottom. So that cancels, leaving me x over 5x minus 1. All right, so for our last example, example 6, it is actually just a really long division problem, like you're just dividing over and over and over again. So you have 1 over x squared minus x minus 6, all over x plus 3, all over x squared minus 9. So the first thing you want to do is just remember, let's go ahead and factor some things. Let's factor this guy and let's factor this guy. So x squared minus 6 minus x minus 6, that's going to factor into x plus 2 and x plus 3. And then over, we have x plus 3. And then x squared minus 9 factors, that's difference of squares, so that becomes x plus 3 and x minus 3. Okay? So from here, we have to realize what we are actually doing. We are simplifying, right? We're dividing, okay? So if we were to try to get rid of this x plus 2 right here, right, by multiplying everything by x plus 2, and then try to get rid of the x minus 3 by multiplying everything by x minus 3, what we would end up with would be x plus 3 over x plus 3, x plus 2. Okay? So again, this cancels. All right? And then you're left with your x plus 3. You're left with an x plus 2. Okay? So from here, you can simplify one more time because we have x plus 3. So that becomes 1 over x plus 2. All right, so what we had to do is we had to multiply the numerator and the denominator by the common denominator. So if I'm looking at x plus 2, x plus 3, x plus 3, x plus minus 3, the common denominator would be x plus 2, x plus 3, x minus 3. So I had to multiply everything by x plus 2, x plus 3, x minus 3. Same with everything over here, x plus 2, x plus 3, x minus 3. And when I did that, that's how these things canceled out. All right. All right, and that's all.